This video will be about analyzing data. So when you're analyzing data, a data is a whole bunch of numbers. It could be just a list of numbers, could be a set of ordered pairs, it can mean a whole bunch of things. So analyzing data can either be a list, can be ordered pairs, and there's more options, but those are what we're going to focus on. So when you're analyzing data, there's three different ways your ordered pair types of data could be set up. The first, if we set up our ordered pairs and put them on a graph, and they kind of go in the general direction of up and to the right, this is called a positive correlation. This would be something like, as a child gets older, they get taller. So the older you get, the bigger those numbers get, the taller you get. If you're going in the other direction, so start top left and go to bottom right, that's called negative correlation. And if there's no kind of direction, it's not going up and to the right or down and to the right, there is no correlation. So what we can do with our data is we can analyze it using what's called a measure of central tendency. So when they use that fancy word, measures of central tendency, they're looking for things like the average or the number that occurs most often. Now these measures of central tendency are usually applied to just lists of numbers instead of ordered pairs. So first there is the mean. That's another word for average value. And the mean is the sum of the data divided by the total number of data, however many numbers are on the list. Then we have the median. That's basically the word for middle. And that's the middle number when they're in order. So it only works if the data is in order. Mode occurs most often. And the range is the highest number minus the lowest. So let's say this is our list of data. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 numbers. So if we're going to find the mean, it doesn't matter what the order is, so we can just use what's already written. We add them all together. And then since there were 11 numbers, we would divide by 11. So add it all together, 20, 30, 45. There's 45 when they're added all together. And if we do 45 divided by 11, that gives us 4.09, or if we were to round, 4.1. So that is the mean, that's the average value. Then we would want the median. Now the median, the numbers need to be in order. So looking at our list of numbers, 1 is the smallest. We have a 2 next, we have a couple of 3s. We have 1, 2, 3, 4 3s. We have a 4. We have a 5. We have a 6, 7, and an 8. So now they're in order. We want the middle number. So I just cross out the first, the last, the second, second to last, third, third to last, fourth, fourth to last, fifth, fifth to last. What's left is the middle number, so the median is 3. The mode will also be 3 because mode is the number that occurs most often, and there are 4 3s. That's the number that repeats the most. And then the range is the biggest number, 8, minus the smallest number, 1. So the range would be 7. So that's how we find the mean, median, mode, and range. We can also use the mean to find a score or a value that we want to have a certain average. So for example, let's say we're cutting some wood lengths, and we currently have wood lengths of 36 3/4 inches, 36 3/8 inch, 37 1/2 inches, and a value we don't know, so I'm going to call it Z inches. We don't know what it is, so we give it a letter. Let's say we know the mean is 36 5/8 inches. Now, first of all, it's going to be hard to work with this with a whole bunch of fractions. So I'm going to change these to decimals. 36 3/4 is really 36.75. 36 3/8 is 36.375. 37 1/2 is 37.5. And then 36 5/8 would be 36.625. Now, if you're not sure how to find the decimals, I just plugged the fraction part into a calculator. 3 divided by 4 gave me 0.75, so 36.75, or 3 divided by 8 gave me 0.375, so 36.375. So now when we go to find the average of something, we add up all the numbers. So we have these 3 decimals plus the value we don't know. 36.75 plus 36.375 plus 37.5 plus Z. And you divide by the number of data. Z is included in the number of data, so there's 4 pieces of wood. Then it said the average length, the mean, was 36.625, so we already know what the average should be. Now we have to solve this for the letter Z. So to get Z alone, first we'd have to do the opposite of dividing, and this big bar means divide. So we'd have to times by 4, because opposites cancel each other out. But what you do to one side, you've got to do to the other. So we have 36.75 plus 36.375 plus 37.5 plus Z equals 36.625 times 4 is 146.5. So now all these things on the left are like terms. They can combine together. So we want to add 36.75 plus 36.375 plus 37.5, 110.625. Now we do an opposite again. We would need to minus 110 from both sides. 110.625 from both sides. And we plug that into a calculator again. 146.5 minus 110.625 is 35.875. So that would be the length of the fourth piece of wood in inches, so that you have an average of 36 and 5 inches. So the last thing we can do is, when you have a lot of data, sometimes it's good to organize it in something called a stem and leaf plot. So let's say we have this for our data. So to do a stem and leaf plot, the left side we call our stems, the right side we call our leaves. And when they do the stem and the leaf is just the last number on any of these. So like 1, 7, 3, 7, 3. Last number is the leaf. Any numbers before that is the stem. So the stem might have 2 digits or 3 digits. Any numbers before the last number is the stem. So if we were to put this on our stem and leaf plot, 31, I'm going to be putting it down a little bit so we have room for the ones that start with lower numbers. So 3, then 1. Stem goes here, leaf goes here. 57. 5, and then 7. 123. 12, and then 3. 17. 1, and then 7. Now this is where it's a little bit different. 13 has the same stem. We don't have to write it again. We just write the leaf. So 1, and then 7, then 3. And actually, I should have maybe put the numbers in order first, because really it should be the 3 first, and then the 7. So 13, 7, they usually put it in order. 21, 27, so I only have to write the 2 once, but then I can write the leaf of 1 and the leaf of 7. And 35, so we already have a 3, but we don't have the 5. So that's a different way to organize the data, and it helps put the data in order. Now, they can have a stem and leaf plot like this, or they may, sorry, I'm trying to scroll down, not move the entire screen. They may use decimals. So if we took some of this same data, I'm not going to do the whole thing, just some of it. If we took some of this same data and did a stem and leaf plot again, we'd still put the 3 on the left and the 1 on the right for 3.1. And we'd still put the 5 on the left and the 7 on the right for 5.7. But what they would do is down below, and they'll tell you every time, they'll say something like 3, and then they'll put the line, 3 then 1 means 3.1. Or, if they take the same thing and say 3 then 1 means 31, then you'll know whether you're using decimals or not. So that covers all our topics for analyzing data, and that concludes our video.